Hi there, learners. Today we're going to continue with some math review. Yesterday you reviewed your doubles. Today we're going to take what we know about the doubles and use our strategies of doubles plus 1. As you can see on the anchor chart on our screen, it shows you the doubles that we have worked with and learned this year. It also shows you how you can just use our doubles plus 1 by taking what you know about doubles and adding 1 to get your new equations to help you quickly solve. We're going to look at some examples of how we can use our doubles plus 1 strategy to solve for missing numbers. Let's look at some examples. So my first problem says it's 6 plus 7 equals something. I also have our part-part whole, also known as a number bond diagram, at the top. I'm going to try and figure out the whole, which is my biggest number. One strategy that we've learned is to think about our doubles. So a doubles fact that I know is 6 plus 6 that can help me quickly get my answer. I know 6 plus 6 equals 12. But I also know that my equation that I really want to look at is 6 plus 7. So if I know 6 plus 6 equals 12, I know 7 is one more, I know that 6 plus 7 equals 13. Let's add that to our diagram as well. Now that I know all the parts of my equation, I have my two parts and my whole, I can use these numbers to think about my fact family. In a fact family, there are 2 addition equations and 2 subtraction equations. And I know when I have this type of fact family, the only numbers that switch places are going to be my parts. And in our case, our parts are 6 and 7. So let's switch those numbers to get our new equation. So I'm going to switch 7 and 6, and I get the equation of 7 plus 6 equals 13. When I'm subtracting, I know I always take away from my biggest number or my whole, so I'm going to start my subtraction equations with my whole, which was 13. That leaves me with my parts of 6 and 7. To complete my equation, it's going to be 13 minus 6 equals 7, or 13 minus 7 equals 6. Because again, the only numbers that switch places in my equation are going to be my 2 parts. Let's look at the next example. Here, I notice that I'm missing a part, but my equation that I'm given is 9 minus 4 equals something. So here I want to think again about what doubles fact I can use to first solve my problem. Well, I see the number 4 as one of my parts. So I can think of a double, which is 4 plus 4 equals 8. I know 8 is 1 less than 9, so I know I need to add 1 more, which gives me the new equation of 4 plus 5 equals 9. My missing number must be 5. I'm going to write that in our equation and in our diagram. Now let's take what we know about fact families to finish off our missing equations. So again, my whole was 9, which is my biggest number, and my only 2 numbers that switch places are my parts. So here I'm going to switch my parts again, which are 4 and 5, and I'm going to get the new equation of 9 minus 5 equals 4. That leaves me with my addition problems. And when I'm adding, I always add my parts. My parts, again, were 4 and 5. So let's write our equations. That was 4 plus 5 equals 9, or 5 plus 4 equals 9. Great, let's look at another example. All right, this example again is showing me that I'm missing a part. What can I do? I notice one of my parts is the number 11. But I also noticed that my whole is the number 20. There's a doubles fact that we've learned, 10 plus 10. So my doubles fact I'm going to use to help me solve is 10 plus 10. I know 10 plus 10 equals 20. But I want to get to 21. So I know that my number or my equation should be 10 plus 11 equals 21. Let's add that to our equation and to our number bond. My missing number was 10. Now I'm going to use my fact family numbers and what we know about fact family equations to help me solve for my missing equations. Again, when I'm subtracting, I start with my whole, which we know is 21. And the only numbers that switch places are my parts. So my new equation is going to be 21 minus 10 equals 11. And when I'm adding, I always add my two parts, which are 10 and 11. So that means my equation is 10 plus 11 equals 21, or 11 plus 10 equals 21. Let's look at one last example. Remember, we're trying to think about a doubles fact that can help us solve quickly. So my new equation is going to be 2 plus 3 equals something. I notice that these are my two parts, so I'm looking for the whole. The doubles fact that I know that can quickly help me solve this is 2 plus 2. So I'm going to write that. 2 plus 2 equals 4. And 3 is 1 more than 2, so I know 2 plus 3 equals 5. My missing number was 5, so let's add that to our diagram. Now fill in the missing numbers or missing equations. So remember, when I'm adding, I add my parts, and since I already have 2 plus 3 equals 5, my equation would be 3 plus 2 equals 5. And when I'm subtracting, I always start with my whole. So my whole was 5. I'm going to add that as my wholes. And then I'm going to subtract one of my parts. So when I subtract 2 from 5, I get 3. Or when I subtract 3 from 5, so 5 minus 3 equals 2. Now it's your turn. You're going to practice writing your fact family equations. Make sure you're thinking about your doubles facts that can help you solve quickly as you use your doubles plus 1 strategy today. I know you'll do great. Good luck.